No one likes running out of something important, especially when it comes to the power, keeping our devices energized. As applications advance, we depend on battery power, now more than ever. Texas Instruments developed Dynamic Z-Track technology to help designers extend battery runtime by as much as 30%. This adaptive algorithm allows TI's new battery gauge ICs to achieve 99% state of charge accuracy to make electronics even more reliable. Now design engineers can be ready for the next wave of applications.
It's an infrastructure that allows for every battery to be continuously monitored and assures its impedance update across the whole life of the battery, regardless of the aging, regardless of the load, regardless of any conditions. And it will allow us to maintain high accuracy, not only for gauging and state of health indication, but also for all the additional other services that our BMS provides.
So you exactly know the remaining capacity and the full charge capacity of the battery. So you get more out of the battery if you're able to track resistance very well.
So we originally started developing the Dynamic Z-Track algorithm on drones and power tools. Those were two applications we identified as needing very accurate battery management. While we were doing that, the emergence of AI PCs came up. They have very power hungry and very dynamic loads. Those are very hard to track with traditional battery gauging methods.
As devices become more critical in human life, it is also more critical that they don't have unexpected shutdown.
So you can actually set your terminate voltage lower with Dynamic Z-Track because we are within 1% error.
And we can predict when that profile will reach the voltage at which system will shut down. So that gives us the predicted runtime under any conditions.
TI's team developing Dynamic Z-Track worked to turn a complicated problem into a small and efficient battery gauge solution.
The challenge was to achieve a simple implementation that can actually fit into these tiny devices and yet solve basically arbitrary complex load problem. I don't need actually the computer in front of me to think about algorithms. One of my favorite activities is to walk in the park between the big trees. Nature is the ultimate source of beautiful and complex things.
At first glance, nature often appears simple. Yet a closer look reveals something remarkably intricate. Just like how Dynamic Z-Track's optimized code is actually derived from years of work with very advanced algorithms.
This is actually a classic case where the simplicity comes out of complexity. So we are using understanding of the whole and quite complicated data processing, quite complicated offline data processing, in order to find those focal points that we can fold this complicated structure into simple structure. That allows us to simplify what will happen in the firmware to the minimum required computations. Basically, we have to be unnoticeable for the system, from power consumption, from size, even from cost in a way.
So Dynamic Z-Track gauges can actually help designers save about 25% of their board space because it integrates the gauge, the monitor, and the protector into a single chip solution.
Some of the things cannot always be solved by just tweaking the parameters. At some point, you have to make a radical change. For me, at the moment when I realize exactly, yes, it can be solved, that is the most interesting moment.
Innovation comes from those who ask, what if, and why not? The battery teams at TI are committed to extending our expertise through research and relentless testing.
So we've spent years looking at batteries. We have over 5,000 battery cells characterized in our system, and we've used that data to help accelerate us into next generation algorithms.
Battery modeling is the heart of gauging. If you don't have a good model of the battery, you're not going to have the best accuracy for capacity simulation or capacity prediction.
We have all of these chemistries and different cells characterized so we can see these different behaviors under different conditions.
As long as you have a pulse load, you have that big transient, right? The transient voltage, if you're able to track it very accurately, you know exactly how to model the voltage.
We can use that resistance to, for example, compute the heat flow inside the battery, which allows us to predict the temperature rise. We can use the same resistance to predict the voltage drop across the battery, and we can measure that current itself, and not just current, but also power. That allows us to make a future prediction. That is what we're literally predicting the unpredictable. We're predicting the future voltage profile.
Then you know when the battery is old or has aged, has been cycled for many times. So you get the appropriate amount of cycles that you want to get out of the batteries.
TI's portfolio of battery gauges with dynamic Z-Track technology helps designers create more reliable electronics with exceptional state of charge accuracy and extended runtimes, even for applications with unpredictable loads. MT has never been further away.